Moving on now to expansion of brackets. This is the same principles that you apply in algebra, you apply in Surds. Let's have a look at this first one. Okay, we've got 7 times root 2 is 7 root 2 and you stop. And 7 times minus 3 is minus 21 and you stop. Root 3 times root 2 is root 6 and you stop. And root 3 times 7 is 7 root 3. Okay, let me do that one for you again, just so you can see here, please. Okay. So if you're multiplying root 3 by root 2, it's root 6. And if you're multiplying root 3 by 7, it's 7 root 3. Okay. So just make sure, please, you understand that. All right. When you're multiplying two surds, you end up getting that. When you're multiplying a surd by a whole number, you just get the whole number in front of the surd. Okay. This is no different to doing a times 7 is 7a. Okay. So going back to this question now, root 3 times root 2 is root 6 and you stop. And root 3 times 7 is 7 root 3 and you stop. Okay, the next one, root 5 times root 5. There's no need here, please, there's no need here to do root 5 times root 5 is root 25, which then becomes 5, okay? That's too much. We know when we look at the question that when you take any square root, okay, when you take any square root and multiply it by itself, the square roots cancel. So you can just go straight to 5 there. So root 5 times root 5 is 5 and you stop. And now root 5 times minus 2 is minus 2 root 5 and you're complete. Next one. Let's have a look. Keep it simple. Okay. 2 times 4 is 8, so you write down 8. And root 3 times root 7 is root 21. So that's that one complete. And now 2 root 3 times 4, you times the whole numbers, is 8 root 3. And that's complete. All right, question 5, we have to apply the rules for binomial products. So first you do 5 times 7 is 35 and you stop. 5 times that is minus 5 root 2 and you stop. Now we'll do root 3 times 7 is 7 root 3 and you stop. And now when you multiply these you get minus root 6. Please always check, and I haven't mentioned it here, but these surds can't be simplified, right? Always check if they can be simplified. That can't be simplified, that can't be simplified, that can't be simplified. Otherwise you will lose marks. Let's have a look at this next one. Root 6 times root 5 is root 30 and you stop. Root 6 times root 2 is minus root 12 and you stop. Now, minus root 2 times root 5 is minus root 10 and you stop. And now, minus root 2 times minus root 2 is plus. Just go straight to 2. Okay. Remember, any square root times itself. So root 2 times root 2 is just 2. So now, can that be simplified? No, it can't. Can that be simplified? Yes, it can. Can that be simplified? No, it can't. So that's root 30. Now the root 12 is 2 root 3. Okay. Excuse me. Okay, question 7 now. So question 7, this is when it's very handy to remember your rules in the algebra. So remember, a minus b all squared is the first one squared minus 2 times the first times the second plus the second one squared. Okay, that's one of your rules. Your next rule is a plus b all squared is a squared plus 2ab plus b squared. They're called your perfect squares rules, okay? And your third one is, of course, your difference of two squares. A plus b times a minus b is a squared minus b squared. These become very useful when it comes to surds, okay? They become very useful. So please make sure, you should know those off by heart anyway. All right, so now applying rule number 1 to this question. So it's going to be the first one squared minus 2 times the first times the second plus the second one squared, which is going to be 5 minus 2 root 10 plus 2, which is 7 minus 2 root 10. Your next one is a plus b times a minus b. If you look at the brackets, this bracket and this bracket are identical. The only difference is the sign. Okay. So you're going to apply the third rule here, where you're simply going to do the first one squared minus the second one. You see, it's taken a very complex question, or what looks like a complex question, and simplified it. Now, 3 root 5 squared is 9 times 45, because you've got to square the 3 and square that, so it's 9 times 5. And 2 root 7 squared, you've got to square that and square that, which is 4 times 7, which is 28. And 45 minus 28 is 17. So 17 is the final answer for that one. All right, that concludes the expansion of brackets. So we've now talked about simplifying surds. We've talked about multiplying and dividing by surds. We've talked about addition and subtraction of surds. And we've talked about the expansion of brackets. So that concludes a majority of the surds topic. The only thing that's left over is rationalizing the denominator. And what a lot of schools do is they'll do up until this point in year 9, and then they'll do rationalizing the denominator in year 10. That's what most schools do. Some schools do the entire topic, including rationalizing the denominator in year 9. So that will be the next section coming up shortly. Okay, good luck practicing.